Okay, so in this tutorial, I will be verifying the vertical distribution of earthquake using this formula. Okay, or in my students' uh, solution, this is the format that I required them to do, wherein wherein you plot the levels, okay, with their corresponding height from the ground floor. Okay, so the second floor has a vertical elevation from the ground 3.8, third floor is 7.2, so on and so forth. Then you will tabulate the weight per floor and simply multiply these two. You will have this, and get, of course, the summation of all this, which is here, and find the factor. So simply divide each value here to the summation, which we have this here, and then insert the base shear that you computed, and simply multiply this datas. Then you will have the corresponding uh, horizontal shear per floor. Okay. Okay, so this is the earthquake parameters that they obtained. Okay, the near source factor, the CACV, NANV. Okay, and this is the where is the weight computation here. So this is the sample weight computation. So I did what I did is I got just the weight per floor, the fifth floor weight, the fourth floor weight, third floor, fourth floor, third floor, second floor. Okay, and pasted here, okay, to the spreadsheet. Sorry, here I placed it here, and then plot the height per floor, and this is the WHI. Okay, summation of WHI. Sorry, this is the summation of WHI, and then this is WHI per level, and then this one is the total weight, summation of weights, and this will be the corresponding base shear or horizontal shear per level. Okay, now to get the base shear, so I just paste or copied the seismic parameters that they obtained. For now, these are all. The structure is a hypothetical one, but the structure is a concrete, so C sub t is 0.0731, period is 0.6187 using the method A formula, wherein period is CTH raised to 3/4. Okay, and these are the height, okay, NANV, CACB, and according to our NSCP, using the four formulas, what governs is this, okay, which is the Vmax, as you see. And I've always said that in a typical low-rise building, Vmax will most likely govern, okay, because your actual base shear formula, you got 36,000, which is larger than the Vmax. So the code said that you should not exceed the Vmax. So this governs. Now we will try to verify if how STAAD do the same vertical distribution of this base shear. Okay. So I modeled the building frame, okay, here, okay, this one, and this is the corresponding structural plan, and you just have to simply copy the required uh, column spacing, okay, 4 5 6, okay, yeah, with your total of 52 meters, and also here, okay. But again, the primary uh, requirements here is how does STAAD distribute vertically the base shear. So that's our only goal here. Okay, from after computing the base shear, how will it distribute vertically? Okay, and is it complying with the code? Okay. Now this is the equivalent STAAD model. Okay, and of course I need to make sure that I follow the same height, so that what else? So that I can check if STAAD was able to distribute vertically like this the base shear. So for example, our second floor is 3.4. This one should be 3.4 also. Okay. Third floor 6.8. So this should be also 6.8. 10.2. So this should be also 10.2. Okay, this is 13.6, so this one is also 13.6 from the ground. And lastly, this is should be 17 meters from the ground. Okay, and basically these are all 3.4 column height. Okay, so I'll check this, double click this. Yeah, so this is 3.4 meters in height. This one is also 3.4, 3.4, 3.4. Okay, so just make sure you do the same height according to the plan, okay, from the ground. So we assume that this is the ground. Okay, next is, okay, let's proceed to the loading. Okay, now as a trick, I need to quickly insert the weight per floor, right? So you can imagine that if I view this front view, so I need to insert the weight per floor in this model. Okay, and of course that should follow the weight that we lumped or we got from our spreadsheet. For example, here, this one. So what I'm saying is I lumped all the weight, these weights here. So for example, this is the second floor weight, 14,836. So what I did is I inserted a weight here, which is 14,836.26. So third floor is also the same, fourth floor is also the same, fifth floor is 14,695.6, while the roof level it's 12,050.23. Okay, so I did that by creating a reference load. For example, here, definition, reference load, as you see. So these are all the weight per floor. Okay, so this one 14,836, 14,695, and 12,050.23. Okay, so the purpose of this is if I already established the reference load, I can now use this reference load or weight per floor as a mass to our seismic definition. Okay, so now on our seismic definition, double click or expand. Okay, so as you see, this command is using this reference load above as the seismic mass. Okay, and this one is the seismic parameters. Okay, so I'll double click this one, and of course it should be the same with our seismic parameters here. That one. Okay, so I have zone 4, importance factor 1.5. This is hypothetical, right? 3.5 as R, soil type 4. Okay, near source factor NA 0.98, 1.16 NB, and CT value as 0.0731. Okay, so using the same seismic parameters and mass, of course, STAAD should consider or should come up with the same base shear. Okay, so let's see, close, and then load case. So of course I just made a primary load case just to avoid an error in the model. Okay, so again, the only purpose of this video is to only to verify the vertical distribution. Okay, so with that, and then analysis, run. Okay, run analysis. And then let's check the base shear. Okay, and compare with our spreadsheet here. Okay, so what do you see? Oops. Okay, as you see here, oops. So STAAD also obtained the same base shear. Okay, 32919. Okay, and period is 0.612, the same. Okay, and of course the total weight is 71254, which should be this one. Okay, again, this is hypothetical. As I said, as my correction to my student, it should be 8.5. But again, the concept is only to verify the vertical distribution. Okay, since we now have the same base shear, we should now verify if STAAD was able to distribute vertically this base shear the same with how the code distributed. Okay, so similar to this spreadsheet. Okay, so to do that, okay, let's now proceed to processing. Okay, then beam results, because we will be checking the shear on each columns. So beam results. Okay, and then view isometric. Okay, so what I did is I created a group. Uncheck moment diagram for each. So you create a group for each column per level. Okay, so that means you will group view. You group all these columns here, and then basically remember the concept is STAAD will be distributing vertically the base shear, something like this. Of course, this base shear will be transferred or will be resisted by all the columns here, right? So therefore, to make sure or to verify the shear, if the shear here to determine the shear on this floor, we will sum up all the shear in our columns. Okay, because columns are the only members that will resist the the lateral, the earthquake force. We don't have shear walls here, so we only have columns. Of course, due to bending, due to sway, frame sway, the girders will also be, be resisting that sway. Okay, so that's what you need to do. So you make a group for each column per floor. So say what I did is I created all this fifth floor to the roof level column as 5C. So okay, this one I call this 4C, the here 3C, 2C, and 1C. Okay, so that's what I did. Now let's proceed with beam results. Okay, and then here right click, result setup, and then we'll just investigate earthquake along X, and then click on range, and these are the groups that I created. So 5C, and then apply. Okay, so this will be all the forces for column, okay, on the 5th floor. And then what do we need to sum up? Okay, now let's recall. Remember, this is our results, view isometric. Okay, now remember, we're investigating base shear along X, okay, EX. Then of course, what resists this are all the columns, right? But what will be the corresponding force on the column? Is it Fx, is it Fy, or Fz? These are the only choices because these are all force. Okay, remember on our convention, Fx is an axial load. Okay, so therefore we have this Z local axis and Y local axis. Therefore, on Ex, this column, if I blow up this column, it has a cross section like this, or isometric view like this. And if you have this Ex, the force that will resist that is along Y. So we call that Fy. Okay? So you will sum up all the Fy. Okay? Because we're investigating Ex. Okay. So I'll copy this. Copy. And as you see, all 5th floor columns are selected, and paste here. Okay. Now to quickly sum up all this Fy, I can just filter that. Filter. And then sum up all the Fy. But as you see, there are positive, negative, because this output is on the bottom and top and bottom of column. So I can hide all the blanks here just to get the positive values. Okay, so unselect all the blanks and then sum up this. Okay, so equals subtotal, and then sum is 9, and then select all this Fy, right? Okay, and then close parenthesis and enter. So as you see, you got 9,533.44. That means all the shear forces, when you sum up all the shear forces in 5th floor, you got 9,533.4. Okay, which is this one. Okay, so makes sense. So these are the horizontal base shear on the roof, or the fifth floor going to the roof. Okay, so how about the fourth floor going to the fifth floor? So I can type it here, 9533.44. Okay, so let's go back to the STAAD model. So right click, result setup, same base shear, earthquake along X. This time I'll be switching on fourth floor going to the fifth. Apply, okay. Then I'll copy this, and then I'll go to the spreadsheet here and then paste. Okay, this is selected. Yeah, so as you see here, the sum now here is 18,834. So I'll type it here, 18,834.5. So that means, so this is, so we need to find the difference. Okay, so equals this minus this. Okay, so that means this is the shear on the fifth, this is the shear on the fourth. Okay, so 9301.06. okay, so almost the same, 9301.06. okay, we got the difference because STAAD is, of course, it's summing up the shear, this two shear already, because you're on the lower level. Okay, so of course if you go to the third floor, it will sum up another shear here. Okay, it will include this shear here. Okay, so let's proceed with the third floor. Okay, all the fourth floor columns are selected. So range 3C, apply, okay. Then copy, then paste here. So 25877.09. So I can just drag this here. So that means the third floor shear is 7,042.59. So let's observe. So the same. Okay, 7,042.6. Okay, so how about the second floor? And on the first going to the ground, ground going to up, going to the second floor. This one is second going to the third. So that will be result setup, this time 2C, then apply, okay. So of course all the second floor columns are selected, copy, and then paste, getting 30,572.14. Drag this here. So 4695.05. Maybe I can 4695.05. So check. So the same. Okay. And lastly, result setup 1C. Apply, okay. Okay, and then copy, then paste here. So see, we're now able to get the total base shear, which is this one, 32,919.67, because, and drag this. So therefore on the first going on the second, we have 2347.5. Okay, so that means STAAD was able to capture this same vertical distribution of base shear on our frame.